Okay, we're back. Sorry about that non-interruption there, but for video 2, we're going to start with Charles' Law number 1. Now, do I need to remember what Charles' Law is? No, absolutely not. What I need to remember is that I can plug anything into the combined gas law. So, again, using this, Charles' Law, let's see, I have a temperature inside my refrigerator that is 4 degrees Celsius. So the first thing I'm going to do is add 273 to that and make that 277 Kelvin before I decide if it's my T1 or my T2. And then I've got 22 down here, so that's 295 Kelvin. Okay, if I place a balloon in my fridge, initially has a temperature of that, so that's T1. So I'm going to put it on this side, equals 295 Kelvin, and a volume of 0.5 liters, so that's V1, 0.5 liters, and so then 277 is T2, so that's here, times, and they're asking me what will be the volume, so they're asking me what would be V2 here. V2 is X here. So I have 0.5 times 277, enter, divided by 295, enter, equals 0.469. 0.469 liters. Now, the temperature went up, the volume went down. We know that they're inverse relationships, so this is a valid answer. Is it close to 0.5 liters? Absolutely, very close to 0.5 liters, so it doesn't upset me at all. X equals. So X equals 0.47 liters. Love it. Okay, number 2, a man heats a balloon in the oven. If the balloon initially has a volume, so I have a volume, a V1. I have a V1 of 0.4 liters. And a temperature of 20 degrees, so 273, that's 293. And that is T1, so that goes on the other side. 293 Kelvin. What will be the volume of the balloon after it heats to 250 Celsius? So 250 plus 273, 250 plus 273. That's 523 Kelvin here. 523 Kelvin there. So 523 goes on this side. So 0.4 times 523, enter, divided by, I have X liters here, divided by 293, enter. So I have 0.713 liters. And as it's almost a doubling in temperature, I would expect to have almost a doubling in volume. 0.713, 0.4, that's almost double. So X equals, so I like that answer. X equals 0.713 liters. Maybe I should circle my answers, that way everybody will know my chicken scratches from my answers. Okay, on a hot day, potato chip bag. If I have a 250 milliliter bag at a temperature of 19 degrees, so I have a volume 1, 250 milliliters. Remember, I don't have to convert that to anything. And I have a T1 of 19. 273 plus 19 equals 292. That goes on this side. And do I have a volume 2 or a temp 2? I have a T2, which is 60 plus 273, enter. That's 333, that goes on this side. Remember, degrees Kelvin. Remember, this is T2, this is T1, this is volume 1. This is volume 2 I'm solving for. need to move all this up. Do I have everything on there? Okay. Okay. 250 times 333, enter, divided by 292, enter. 285 milliliters, 285 milliliters. X equals, and it makes sense. If the temperature goes up to this, then the volume had to shrink. Remember, inverse. Okay, X equals 285 milliliters for number 3. 285 milliliters. And remember, if I use milliliters on this side, then my answer is in milliliters. Whatever volume I use, it's the same over here. Okay, let me close that door really quick. All right. That's number 3. Number 4. Okay, number 4. A soda bottle is flexible enough the volume of the bottle can change even without opening it. If you have an empty soda bottle, which is a volume of 2 liters, so I have a V1 of 2 liters at room temperature, 298. That's 25 is going to be 298, right? So that's looks like that's my T1, which goes on this side. This is what y'all will forget when you're doing it this way instead of working it the other way where you do P1 V1 over T1. Maybe I'll do the last couple that way. Okay. What will the new volume be if you put it in your freezer? -4 degrees, so that's 269, so that goes on this side. And X volume. So this is our V2 that we're solving for. So 2 liters times 269, enter, divided by 298, enter. X equals 1.805 liters. So X equals 1.805 liters. And that makes sense because if I put a soda bottle from a room temp into a freezer, before it freezes, the volume of gas in it, well, if there is no liquid in it, it won't freeze, but the volume of gas will decrease. Have you ever seen a gas can that you leave out overnight on a cold night? If you leave it out overnight, it gets smaller. The sides suck in. Wait a minute, here, let's get in the camera. The sides suck in, so it makes a dented in gas can. So this makes sense that it would get smaller and take up 1.805 liters. All right, so we're going to solve the rest of them with the new and approved P1 V1 T1 equals P2 V2 T2. Because, if you want to solve things that way, we can solve things that way. So let's do it. We're going to solve number 5. Number 5. Some students believe that teachers are full of hot air. Yeah, I am absolutely a gas bag. If I inhale 2.2 liters of gas at a temperature of 18 degrees and it heats to a temperature of 38 degrees in my lungs, what is the new volume of gas? Okay, so I have a volume 1, 2.2 liters. Let's do it right here, number 5. 2.2 liters. That's my volume 1. And I don't have pressures. But I do have a T1, which is 18 degrees. 18 plus 273 equals 291. 291 Kelvin equals, and then in my lungs it heats to 38 degrees. 38 plus 273 equals 311. So that's going to be my T2. And I'm looking for X. Okay. So it's 2.2 divided by 291, enter, times 311, enter. X equals 2.35 liters. And again, 2.35 liters. I started out at 2.2 liters. I like that. It's not a crazy difference, so it's not 9,000 liters. So I like that answer. So 2.35 liters. 5 liters. We like that answer. Let's do number 6 here. Number 6. How hot will a 2.3 liter balloon get to expand to a volume of 400 liters? Assume that the initial temperature of the balloon is 25. So my T1 is 298 equals. And my T2, I don't have. And my V1 is 2.3 liters. And my V2 is 400 liters, which is a crazy big number. All right, so now I just got to solve for x. So 2.3 divided by 2.3 divided by 298, enter. And then 400 divided by that answer, 51,826 Kelvin. That seems like a really ridiculous number. 51,826 Kelvin. But let's think about this. 400 divided by 2.3. This expanded in volume 173 times its original volume. If I multiply that times 173, guess what I'm going to get? 173, 51,000. So this, I hate answers like this. First of all, are you ever going to get a balloon to 400 liters? That seems kind of hard. But yeah, you'd have to increase the temperature to this to get 2.3 liters to expand to that. So it's not my favorite question on here, but number 6 is 51,826 Kelvin to get it to get that big. All right. Let's go ahead and do 7, and then I'll start a new video. So, number 7, I have made a thermometer which measures temperature by compressing and expanding gas. I have measured that at 100 degrees, so that's 373. I have a volume of 20 liters, so 20 over 373 equals. What is the temperature outside of a piston has a volume of 15 liters? 15 liters, X degrees Kelvin, liters, degrees Kelvin. Okay, solving for X again. 20 divided by 373, enter. 15 divided by second answer equals. X equals 279.75 degrees Kelvin. And again, if you're doing a multiple choice test and I see an answer that says 280, just pick it, because maybe they rounded. So for number 7, we've got X equals 279.75 degrees Kelvin. All right, and we'll continue after this.